Guys, Coach Cook here. I'm just going to talk a little about the phase change chart because it is going to be on your test, okay? A lot of people are getting a little of these terms mixed up as far as whether it's melting, where it's doing it, all that sort of stuff. And I've got just a little thing to help you out, all right? So always try to remember this. Anything is heating up or cooling, and if it's in a state of being, okay, a phase, then it's going to be on the upward angles. Anytime you have a phase change, it's going to happen on these flat lines, okay? So, what do I mean by that? Let's think of water. Water is the easiest example in chemistry for 90% of the things we do because we use it every day and we can see it usually with our naked eye, right? And everybody knows what water is. So, let's do this. Our three phases are what? We have solids, we have liquids, and we have gases, okay? Shouldn't be anything new. We all know that those are the three phases of matter, okay? Now, how do we talk through this? If I have a solid, okay, form of water, what is it? It's called ice, right? Okay? So if I have ice and it's going from a solid to a liquid, what has to happen? It has to do what? It has to melt. So guess what? Melting is the first phase change that we're going to talk about. And if you haven't noticed, oh, well, maybe temperature's going up. So that's right. For this chart, as you go upward in the chart, temperature is going to increase. As you go this way, and we're going to get into this more in a minute, energy is going to increase down this way. All right, so melting. If I have a liquid form of water, I have it on the stove, and I'm heating it up, heating it up. What does it do before it starts coming a gas and evaporating or steam? It has to do what? It has to boil. Okay? Boil or boiling is right there. Okay? What's the opposite? If I have gas, okay, because anytime you go this way, you can also go backwards. If I have gas, it's a hot summer night, right? Or excuse me, hot summer day, night's cooler, okay? And then we've all done this. We've all gone outside early in the morning when it's cold and it's dew and it's really wet on the ground. Why is that? Because the clouds come down and it's called condensation. Okay, so it's something very similar to that. When gas goes to liquid, condenses. But condenses, condense. Okay, next, if I have a gas going to a liquid, it condenses. What if I have a liquid, okay, going to a solid? If I have that liquid water and I want it to go down to solid, which is an ice cube, what has to happen? Immediately, you guys should say freezing. All right? So, remember, this way is heating up, this way is getting colder, and it happens on the upward angles. Okay, phase changes happen here. Now, something else we have to talk about. With a solid, its molecules are really packed close together. Okay, with a liquid, they're kind of spread out a little bit more. With the gas, their molecules are all over the place. So, something we need to know for our group and our test. When you have solid, molecules are packed close together. Inter and intramolecular forces are very strong. But as I go to liquid, they're a little bit looser, okay, not as strong. And then if I have a gas, the inter and intramolecular forces are flying all around. So what can we say about that? How can we tie that into this chart? As temperature increases, and you go this way on the chart, inter and intramolecular forces get weaker. Okay, so inter and intermolecular forces get weaker as temperature increases and as energy increases. Okay, energy is being produced the more these molecules are loosened up because they have more movement, and we know that movement means that heat is going to be generated, things like that. Okay, all right. So good phase change chart. You guys do need to know how to label this. Good luck.